Good morning and welcome to webinar number 9 in the Kepware 2020 webinar series from Mac Solutions. Today's topic is adding extra reliability to OPC systems. And the agenda is as follows. First of all, we'll be looking at the function within KEPServer called media level redundancy, which gives a network path redundancy, 2 paths to a device. Then we'll be looking at the system flags in KEPServer, which can be very useful for diagnosing faults and monitoring the status of a system. And then we'll be looking at a driver within KEPServer, which is called the system monitor driver, which is useful for monitoring the system, the OS and the PC hardware. So who is this webinar designed for? It's anyone who really wants to optimize efficiency and reduce downtime. So this could be engineers working on the shop floor who need to diagnose and maintain the systems. So optimum efficiency is what it's all about. Project engineers who might be designing solutions to sit on the shop floor, and perhaps production managers who are always looking for ways to optimize efficiency and reduce the downtime by adding small steps to improve things. So on to the first element within the presentation. This is related to network path redundancy. So as we all know, Ethernet networks form the backbone of all shop floor comms these days. But it's often overlooked that network devices and components are a single point of failure. You can employ industrial Ethernet switches, especially the self-healing ones that can go clockwise and counterclockwise to give 2 different routes to an IP address, but they don't always solve the issue. So there's other things you can employ as well. So let's have a look at a typical non-redundant topology, a straightforward single network topology. So here we have the red network, and you can see there's multiple single points of failure here: the network cards, the switch, the NIC card in the back of the KEPServer computer itself. So if we then add to that, we have the red network, which is the duty network. If you then add to that the second network by employing dual network cards in the PCs and the PLCs, you then have a blue network, which is the standby network. Of course, you then have 2 routes to reach the PLC, but once you then add a dual path, you then need a switchover mechanism. So you need to be able to switch from the duty to the standby, and then you need to be able to switch back from the standby back to the duty. So where does that switchover mechanism reside? So option 1 is to put it in the client. So the client has to have the path switching rules within it. It must monitor the status of both paths and decide which path to use, which path is best at that time. Often that level of redundancy of the OPC layer is not available for many applications. And if it is, often it's an expensive option. It certainly would cut down your choice if you're looking for an OPC client, if you have to look for one that has this switching capability. So the second option is to put it in the OPC server. So the OPC server must monitor the COM status of the paths and decide which path to use at that particular time. The advantage of that is the client or clients need no redundant aware capability. They're not doing the switching. The KEPServer itself will be doing the switching. And this is a feature called media level redundancy, which is included within KEPServer, and it's included for all drivers which can use a media which can support 2 paths. So all Ethernet drivers, for instance. So that's a feature which is included within KEPServer. It's no cost. It's part of the core. It's not a plugin you have to pay for or anything of that nature. So media level redundancy works as follows. First of all, you configure the first channel, which we will call the primary channel, which is the red channel here. And then you copy and paste the channel and PLCs, the devices on that channel, to a second channel, call it the blue channel, which is the secondary channel. You then specify that the devices on the secondary blue channel are failovers for the devices on the primary red channel. So it's very straightforward to do. It's once you've done everything once, you then copy and paste the devices, and you've done it in a couple of minutes. Now, you might think at this stage that the OPC client over here must use a different path to reach the PLCs, because if it's connecting through the red network or connecting through the blue network, it's actually using a different network card within KEPServer, and it's using a different channel. It's using the secondary channel rather than the primary channel. But the clever thing is, the media level redundancy function always maintains the names, the OPC tag names of the primary path. So the OPC client will be unaware that the KEPServer has decided to move across from the red primary to the blue secondary network. It would simply ask for the primary path all the time and get the values back, and it would be none the wiser that the primary path has actually fallen over and the secondary path is being used. So that's very clever, very neat, and it means that you can use an OPC client which has no redundant or switching capability. So the second topic for today is moving on to the next thing you can do to add reliability and resilience into your system, is to use the KEPServer inbuilt system flags. So these are system tags which are created by the OPC server itself. They're very useful for diagnostics and for monitoring the status. So for instance, if you have a comms failure, then you can identify if the where the failure has occurred. If a PLC suddenly stops communicating, you can see if you've got a global fault with that PLC, if it's stopped communicating for all tags, or it's just a particular tag that you're not seeing. And also it's very useful for monitoring the status of the OPC server itself. So these OPC system flags fall into three different categories. You have system tags which are at the server level, about the behavior of the server. You have system tags which are at the channel level, about the behavior of the individual channel. And then you have system tags at the device level, talking about each device on the channel. Some of these tags are read-only, and some are read-write. So you can read all of them from OPC clients, but some of them you also have access to write to. And the system tags are created by the KEPServer and are accessible just like any other OPC tag that you might configure. So they're accessible to any OPC clients that are connected. Again, like media level redundancy, this is an included standard feature. So it's not something you have to pay for, it's not something you have to buy. It's just there and you can use it. It's much overlooked, and I would recommend you have a look at the system flags in the KEPServer documentation. They're very, very useful. So here are a few examples of the system flags themselves. So you have system flags that sit at the server level, that show things like the number of OPC clients that are connected at any one time, the number of OPC tags that are being polled at any one time. And also you have tags coming from the server which are very useful for use as heartbeats. So you have hours, minutes, seconds, times, and that sort of thing. So they're very good if you want to have an OPC client which is getting an update, and the OPC client wants to check, is it communicating with KEPServer, or has the link between the network link perhaps between that client and KEPServer fallen over. If the network has gone down, you would see the heartbeat in seconds stop updating. So that might be something that you can employ in a client to say that the link to the KEPServer across the network has failed. So another use of the server level tags are the number of clients connected. That's quite useful if you know that you should only have 3 or 4 clients connected, and you suddenly monitor it and you see a very large number. It could be that your clients are disconnecting and then reconnecting, and this is not being done properly. We've had this in the past where people have written their own clients, and where looking at the OPC server, you see hundreds of clients connected because the OPC client has not been written properly to disconnect in a controlled manner. It just falls off and then reconnects as an additional client. So again, this is very useful for diagnosing faults outside KEPServer. On the channel side, you have system flags which are on the channel side. That's useful for looking at the settings of the channel, for instance, which NIC card it's using in the PC, error statuses and baud rates and other things like that. The really useful one, however, is the device level one. So here you have error statuses of individual devices. You have the ability to enable and disable comms globally to a device. That's a flag that you can read and write. And you can also have one called simulate. So this is very useful if you're doing maintenance on a PLC and you want to basically freeze the values for a short time, and you don't want to turn it off, because turning it off will perhaps create a cascade of errors to your OPC client if the values suddenly disappear. You can just freeze the values and simulate. Again, this is a tag you can write to. And this would then allow the clients to see values which are not changing whilst you maybe restart that PLC or maybe do an update on it or something of that nature. And then you can unclick the simulate button and the values will just update again. So that's a very good way of taking putting a PLC into a short-term sleep mode, if you think of it that way. Some people actually use the system level device tags and actually draw a network topology of their a topology diagram of their network, and then overlay on top of that diagram the error statuses, the enable and disable, and the simulate buttons on top of the PLCs, so they can do a network management page based upon these device level tags. So today's third topic is concerning the monitoring the health of the Windows OS and the PC hardware, which is where KEPServer is running. So a little bit of background, obviously KEPServer is running within Windows, and Windows will be hosting lots of different applications at the same time alongside KEPServer. It could be running mainstream applications like databases. It could be hosting specialist software like SCADAs or custom written applications. And unfortunately, malware and also applications which have been installed, which really shouldn't be there. So I've termed those unsanctioned applications, and I'll tell you a story of one of those in a little while. So these software applications can impact what's happening on the Windows operating system, and therefore that will impact what KEPServer is seeing. So you can have memory leaks, you can have memory shortages, you can have all sorts of things happening within the OS, malicious or unintended, which will then cause KEPServer to not behave as it should. You also then have PC hardware. Obviously, KEPServer is running on some hardware, whether that be a VM or a cluster or a cloud or some physical hardware. So you have hard disk health, you have hard disk available space, RAM, CPU health like temperature and speed of fans, the number of and quantity of the Windows threads that are running, or what resources are needed by or being used by Windows at that particular time. So again, hardware failures can cause all sorts of problems with PCs suddenly crashing. If they're not crashing, they can go slow and freeze. So any of these issues within the OS or within the hardware can cause an unexpected, unintended stoppage. So let's see if we can do something about that. So within KEPServer, there is a driver called the System Monitor driver. And the System Monitor driver talks to a range of services provided by Windows, which are related to the performance and management of the system. So this is within the Windows OS itself, and it's something that's provided as standard. All that the System Monitor driver does is tap into that connection and provide all of the tags that would be inside the Windows performance layer or management layer out as OPC tags. So that includes things like the CPU utilizations, the CPU temperatures, and all sorts of things which I mentioned before related to the behavior of the OS and also related to the behavior of the hardware. So you would get an early warning if you had a smart error on a hard drive. That would be an indication the hard drive is probably going to fail soon. You will be able to take some proactive action to swap out that hard drive before it actually comes to a fatal error and crashes. So that's just a simple example, but it's a very, very useful one. Another example, which I mentioned earlier, is the use of unsanctioned software. We had an instance a few years ago where an operator on an oil platform down in South America was using the very powerful server PC during the night shift to copy DVDs. And that was impacting upon the KEP server and impacting upon the SCADA. And it was only by installing System Monitor on the PC and monitoring the behavior of the windows, it was noticed that only when this particular operator was logged in at certain times would this error occur. And we could see exactly what thread was taking all the memory, and we could then dive down and figure out what thread that was, and it turned out to be a DVD writer. So that was very, very hard to diagnose that otherwise. So again, very useful way of monitoring people doing things with the server PCs they shouldn't be. Again, we've had people use this for unmanned installations, on unmonitored installations. I was speaking with a company just last week who were very, very keen, didn't know about this, and very keen to deploy these on the installations they currently have on offshore oil rigs, which are extremely difficult to get to and very costly. So a very useful way of monitoring the status of the offshore hardware and offshore OS actually from an onshore location many, many miles away. Okay, so this is just a recap of the agenda. We went through network path redundancy, the use of the KEP server system flags, and also the use of the System Monitor driver for monitoring the Windows and PC health. So thanks very much for attending today's webinar. My name is Dave Hammond. I'm the product manager for the KEP server software in the UK, and we've been the technical reseller for the Kepware technology since 2001. We also sell two other pieces of OPC software, one from a company called Cogent, which is the Cogent Data Hub, and one from a company called InRay, which is the OPC router. And if you're interested in these applications, which are utilities that sit above KEP server and communicate to higher level systems, then join us on webinar 11, where we will be covering that content. So again, thank you very much for watching today's webinar, and I hope you all stay safe and well.